This is Professor Russell Wilson. This is a division problem. Has to be long division, by the way, because we can't do synthetic division with this type of divisor. It is 2x to the third plus 3 divided into 8x to the 6th plus 10x to the 5th plus 4x to the 4th plus 10x to the third plus 10x to the second plus 6x. The person only put a 6 on there, but I know they meant 6x minus 9. Now, before you start doing it, this is a reminder of the division algorithm, actually. The steps you take for long division: estimate, multiply, subtract, bring down, and repeat until you get to the remainder. By estimate, we mean the largest power in the divisor divided into the largest power of the dividend. In this case, we're not doing 2x to the third plus 3 divided into 8x to the 6th plus 10x to the third plus 4x to the fourth plus 10x to the third plus 10x to the second plus 6x minus 9. I'm good at this. I'm not that good. But so its estimate is just the 2x to the third divided into the 8x to the 6th to start us off with. And what makes 2x to the third 8x to the 6th will be 4x to the third. Notice I'll put it rather conveniently all the way over here to the above the x to the third part. And this is because of the multiply. 4x to the third times 2x to the third is 8x to the 6th. This is no coincidence. We want that to start canceling as we continue the division process. And also, multiply polynomials means you have to use the distributive property. So I also have to multiply 4x to the third times 3, which is plus 12x to the third, which I need to put over here. 12x to the third is 4x to the third times 3. Subtract. What does that mean on your polynomials? Change the signs. You have to change all the signs. So we have gotten rid of the 8x to the 6th. Bring down step. 10x to the 5th plus 4x to the 4th minus 2x to the 3rd plus 10x to the 2nd plus 6x minus 9. And then you keep going until the very end where you can't go any farther. That the very end would be your remainder. So estimate what makes 2x to the third 10x to the 5th a plus 5x squared, quite conveniently over the x squared terms. And it works because 5x squared times 2x to the third is 10x to the 5th. Distributive property says you have to multiply 5x to the second times 3, 15x to the second. Then you just go over here, plus 15x to the second. We're almost done, believe it or not, with this really big problem. Minus means change all the signs. The 10x to the 5th goes away very nicely, as well it should. Bring down, this case, means 4x to the 4th minus 2x to the 3rd minus 5x to the 2nd plus 6x minus 9. Repeat again. Keep going until we can't go any farther. What makes 2x to the 3rd 4x to the 4th is a 2x. Makes sense. X to the 3rd, x to the 2nd, x to the 1st. 2x times 2x to the 3rd is 4x to the 4th. 2x times 3 is 6x. Right, way over here. Plus 6x. Minus means change the signs again. The 4x to the 4th cancel out. This must happen or else you did something wrong. So now I have a negative 2x to the 3rd minus 5x to the 2nd. And this happens to cancel out, which is kind of nice. That doesn't always happen. Minus 9. I have one more estimate to do because I can do how many times 2x to the 3rd goes to the negative 2x to the 3rd, which would be a negative 1. I've come to the end of the line on the quotient anyway. Negative 1 times 2x to the 3rd is negative 2x to the 3rd. Negative 1 times 3 is negative 3. One more time, minus means change the signs. The negative 2x to the thirds go away. So our remainder is going to be negative 5x to the second minus 6. And the reason it's the remainder because the 5x to the second is a lower power than the 2x to the third. So my answer is 4x to the third plus 5x to the second plus 2x minus 1 plus, let's call it a negative 5x squared minus 6 over the original divisor, 2x to the third plus 3. Let me see. Make sure I got all that on here. And there it is. There's my minus 1. And there's my remainder, negative 5x squared minus 6 over 2x to the third plus 3, the original divisor.